Good morning. I'm Devasena. In this lecture, we are going to discuss about TinyOS, an operating system example in wireless sensor network. Wireless sensor network operating system examples. TinyOS. This TinyOS is specially designed for wireless sensor network. TinyOS is an open source, flexible, component based and application specific operating system. TinyOS architecture is represented in this diagram. TinyOS supports concurrent programs with very low memory requirements. The OS has a footprint that fits in 400 bytes. TinyOS falls under the monolithic architecture class. TinyOS uses the component model, and according to the requirements of an application, different components are glued together with the scheduler to compose a static image that runs on the mote. A component is an independent computational entity that exposes one or more interfaces. Components have three computational abstractions like commands, events, and tasks. Tasks are used to express intra-component concurrency. A command is a request to perform some service, while the event signals the completion of the service. TinyOS provides a single shared stack, and there is no separation between kernel space and user space. TinyOS programming model. Earlier versions of TinyOS did not provide any multithreading support. TinyOS version 2.1 provides support for multithreading, and these TinyOS threads are called TOS threads. The TOS threading package provides the ease of threading programming model coupled with the efficiency of an event-driven kernel. TOS threads are backward compatible with existing TinyOS code. TOS threads use a competitive threading approach. That is, TOS threads rely on applications to explicitly yield the processor. Application level threads in TinyOS can preempt other application level threads, but they cannot preempt tasks and interrupt handlers. For communication between the application threads and the kernel, TinyOS 2.1 provides message passing. TinyOS scheduling. Earlier versions of TinyOS supported a non-preemptive FIFO scheduling algorithm, that is, first in, first out scheduling algorithm. Since TinyOS supports only non-preemptive scheduling, task must obey run to completion semantics. As TinyOS uses FIFO scheduling, disadvantages associated with FIFO scheduling are also associated with the TinyOS scheduler. Two-level scheduling, task scheduling, FIFO scheduling are done. Priority scheduling and preemptive scheduling are also done in TinyOS scheduling. In TinyOS version 2.1, memory safety is incorporated. The goals of memory safety are trap all pointer and array errors, provide useful diagnostics, and provide recovery strategies. Implementation of memory safe TinyOS uses the concept of a deputy. The deputy is a resource-to-resource compiler that ensures type and memory safety for C code. TinyOS communication protocol support. Earlier versions of TinyOS provides two multi-hop protocols. They are dissemination and TYMO, that is TinyOS Dynamic Manette on Demand. The dissemination protocol reliably delivers data to every node in the network. TinyOS uses two mechanisms for managing shared resources. They are virtualization and completion events. A virtualized resource appears as an independent instance. That is, the application uses it independent of other applications. Resources that cannot be virtualized are handled through completion events. There is no explicit support in TinyOS for real-time applications. TinyOS is not a good choice for sensor networks that are being deployed to monitor real-time phenomena. Thank you very much for listening this lecture. If you like this lecture means kindly share this video to your friends. For further updates, kindly subscribe my channel. Thank you.